Hello! We are working on linear relationships still. I hope you're enjoying linear relationships. I love linear relationships. They're a lot of fun.
Me too, me too.
Miss Green likes them too.
Yeah!
I think Miss Newsom's lying to us. But linear relationships, one of the best parts about it is it's not as focused on that multiplying and dividing crazy random numbers. You get to actually deal with the numbers and manipulate them manipulate them into fun ways. So our learning target today, it drives me crazy when your pens go from blue to pink. And I'm like, whoa, different color. Anyways, our learning target is we will be able to represent a situation with an equation, a table, and a graph. What happened to the verbal description?
This one right here. Be able to represent a situation. That's
hey, there we go. I saw her writing something earlier, and then she changed it on me. And she's throwing me off. So make sure your learning target is written down in your journal. So today, our first one, Michelle had $200 saved up and makes $5 per hour babysitting. She really wants that new iPhone 7 for $700. There is no question on this. Miss Green, why is there no question?
Because we're going to represent this situation using a table. And then from our table, we're going to go to our graph. And then from there, we're going to go to our equation.
Yes, we are going to represent.
We're representing the situation.
Represent?
We're representing our situation with a table, a graph, and an equation. So let's start with a table. I'm going to do my XY table. X is going to stand for, what do you think X should stand for? Should it be the hours or the amount that she has saved?
Here we go. No, look. Where's the next page? Here we go, look.
Oh, look at that. Miss Green already created me a table and a graph.
Did.
I'm just sitting here.
Yeah, she is. She's sitting there looking pretty. So we have Michelle had the $20 and she makes $5 per hour babysitting. So we've got MX plus B. Our slope, which is our
rate of change,
Our rate of change.
constant proportionality,
Or slope.
Slope. I already said slope. Our slope.
Or rate of change.
Wow.
or y over x.
Or constant proportionality. Did you already say
Only constant proportionality if it's a proportional
proportional
relationship.
relationship.
This one's not proportional relationship, so it's not a constant proportionality. It's only a slope.
Ching.
So our slope in this is actually gonna be she makes $5 per hour. We know that's being multiplied.
that? Use it.
I know. I can't see that. So we've got the equation of y equals 5x plus what else does she already have?
She has an addition, that $20 that she had
So
already.
plus 20. So 5x plus 20. I'm just taking that information and plugging it to where I know.
Right.
Now, I'm going to create a table. So my process, 5 times 0. So if she works 0 hours, how much money does she have?
Well,
5 times 0 is
0
plus 20, so she has $20. For 1 hour, 5 times 1 is 5. Plus 20 is 25.
I'm sorry, the mental
teacher
math
is
person is writing right now.
Well,
I'm sorry.
I always ask my kids things, and so I usually just kind of ask you guys when I do the videos, and
I'm ready now. I'm done.
they're totally not paying attention to me. They're kind of acting like students today.
That's what we do.
Yeah.
Ready.
Teachers are the worst students.
Teachers are the worst students. So now we've got 5 times 2 plus 20. So what's 5 times 2?
10.
Plus 20 is
30.
30.
I see a pattern.
I see a pattern too.
I don't yet. Let's keep going.
Okay, so 5 times 3
15.
plus 20
35.
is 35, and you'll notice
Oh, I
these are
see it.
changing as plus 5s. Remember how we discussed in our packet, in our linear relationships packet, that we've got the change here divided by the change here?
The change of y over the change of
y
x.
Over the change of x, that's 5. Woo, you're gonna knock the camera over. 5 divided by 1 is 5. That's where we got our slope. That's where we got the 5 there.
So as long as it's going up by the same one and
Yes.
it's going up by the same one, it's going to be a linear relationship.
So 5 times 12. So if she works 12 hours, 5 times 12 is
60
plus 20.
80.
So she has $80. It's gonna take her a while to get that iPhone.
Is it okay that the table jumped from 3 to 12?
It is, because if you look at this change, what is the change from 3 to 12?
I believe it's 9.
So that was a plus 9. What's the change from 35 to 80?
45?
It's 45. If you actually divide this out, 45 divided by 9 is actually 5. So the change is still there. It's the same change.
You know, Ms. Groves, I'm so glad you said that because you know what? I would have made my kids write the table out from 3 all the way down to 12.
You don't
and
have
35
to.
all the way down to 80 so that they can see it is a linear relationship.
I still just did the change.
It is not wrong.
It's not wrong.
I'm joking.
It just makes her kids do a lot more work than my kids. Oh, they're giving each other death
Good luck,
stares
Miss
over
Green's
here.
class. Good luck.
Now let's graph this on a table.
Y'all can go see Miss Leone for.
Who's Miss Leone?
Anymore, so.
1, 2, 3. Would you quit knocking the camera over?
I was just joking, Miss Green's class. I would love to be in her class, actually. So if I can enroll as a student, that would be great.
Okay, I'm going to continue on and graph this. So what we have is we've got 0, 20. So when I have nothing, I haven't worked any hours, I still have $20. So 0, 20 is going to go here.
How is that possible? Because she already had it.
She already had it.
Yeah.
She didn't have to earn that. She had it.
This is our y-intercept.
That is called your y-intercept. That's this number here. It's where it hits that y-axis.
When X is
where
0.
the Y intercepts the line.
Boom.
Okay, so 125 is about right here. 230 is right here. I'm only going to put three of them because it's going to make a nice linear relationship. The rest of them are actually, you could check it, are actually on that line as well. This is linear relationships. We just went from a verbal description to a table to an equation to a graph. It's all there. That's it.
Yep.
Okay, so if I wanted to go backwards, if I wanted if I wanted to go backwards, how would I do it? Let's say I didn't have my table here.
If we cover this up right there.
So if there
I'll
is
use a blank
yes,
sheet.
that
would be
blank one
good.
works. If we had just the graph and there was no table, and I wanted to create a table, I could start with my x, y's. I love to start with where it hits that y-axis.
Okay.
Because I know my x is 0, and I went up 20.
Awesome.
Okay. Now I'm gonna look here. I went 1 up
30.
25.
Oh,
So
25.
1 to 25. Oh, hey,
Is that
this is
half?
kind of easy.
Right.
I'm just finding points on this line, and I'm gonna mark them. So 230. You can see I can go from the graph to
Straight
a table.
to the table.
I can also look at this and I can go, well, what if I have the graph here and I want the equation? Can I do that?
Yeah.
So if I have that y-intercept is always going to be this, what you had without anything. So
When X is...
when it hit it, it's 20.
Yes.
So I've got that. So that means the y equals mx plus b. This is where it hits
Your
the
Y.
y-axis. So that's 20, so plus 20. But what is my m?
Well,
Can-
it's your slope.
My slope.
It's your-
How do I find my slope?
It's
your
rise over run.
Rise over run.
Rise
This is
means-
super important. Rise means going up.
Or down.
Or down.
Or down, up or down. And run means left or right.
Right.
So if I go up 5, I went over 1.
Right.
So I went up 5
Over 1.
over 1. What's 5 divided by 1, guys?
Everybody knows that's a whole number.
So
There's
y
one on the
equals
bottom.
5x plus 20. Is that the same as
Yep.
that?
Done and done.
Easy.
That was awesome. So we'll talk about this a little more. You're going to see it a little more this week. Hope y'all enjoy it.
We
See you
out.
later.
Peace out.